Hello students, welcome to Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem from chapter 5, Hibbeler statics. The problem says that determine the tension in each cable and the components of reaction at D needed to support the load. So we have two cords or two cables. One cable is from A to C and one cable is from A to B, and this rod is supported, and here we have the HD, we have this ball and socket joint. So at D we will have three reactions. The ball and socket joint cannot support the moments, so it cannot provide the moment reactions. So we will have three reaction forces at D. So we will have dx, we will have dy, and we will have dz. Here we have this 40 Newton force, and this 40 Newton force is making 30 degrees with the vertical, that is with the axis which is parallel to the z axis. And let's say that here we have from A to B, let's say this is T1, and from A to C this is T2. So we are required to find T1, the magnitude of T1, T2, and this dx, dy, and dz. So we have to find the Cartesian vector representation of T1 and T2. So now we can write that T1 vector, which is acting from A to B. So in order to write this as a Cartesian vector, we can write that this T1 magnitude times the unit vector from A to B, since T1 is acting from A to B, and we know that T1 and the unit vector from A to B is the position vector from A to B divided by the magnitude of that position vector from A to B. So this is T1, and now the position vector from A to B. So the position vector from A to B can be written in terms of its I, J, and K components. So to write this position vector from A to B, we need to travel from A along the x, y, and z axes to reach that point B. So from A we need to travel this distance, which is 6 meters in the negative x, like this. So we will write that we need to travel 6 units in the negative I and 6 meters in the negative I. Then from this point we need to travel this distance, which is 3 meters in the negative y. This is positive y, so I will write minus 3j. And then once we reach here, then we need to travel this distance in the positive z, which is 2 meters. So this is plus 2k. And then the magnitude of this will be minus 6 square or plus 6 square, that will give us 36. Anyways, this will be, then we will have 3 square plus 2 square, then the square root. So if we find this magnitude, this is 6 square is 36 plus 3 square is 9 plus 4. This gives us 7. So this magnitude is 7. This magnitude is 7. So we can write that T1 vector, this is not approximation, this is exactly equal to 7. So we can write that T1 is, we can divide this each component by this magnitude now. So this is minus 6 divided by 7 into T1. So minus 6 divided by 7 T1, minus 3 divided by 7 T1, and plus 2 divided by 7 T1. And this is, let me write that this is I, J, and K components. So this is the x component of T1, this is y, and this is z component. This is Cartesian vector representation of that tension in the cable which is acting from A to B. Similarly, we need to write T2 as a Cartesian vector. So T2 is acting from A to C. So the Cartesian vector of this T2 will be T2 magnitude times the unit vector from A to C. And then we will write T2, and the unit vector from A to C is the position vector from A to C divided by its magnitude. And now this is T2. And now the position vector from A to C. So from A we need to travel 6 meters in the negative I, so minus 6I, and then once we reach here we need to travel 2 meters in the positive K. So this means that there is no need to travel in the J direction, so we will write plus 0J plus 2K, and divided by its magnitude. So its magnitude will be 6 square plus 2 square. So this will give us 36 plus 4. So this gives us square root 40. This is square root 40. So now we can write T2 vector. So this will be minus 6 divided by square root 40 T2 I plus 0j and plus 2 divided by square root 40 T2 and K. So this is the Cartesian vector representation of that tension which is acting from A to C. So as we can see that the tension which is acting from A to C has 0 component along the y-axis, and T1 has 3 components, I, J and K. So now let's represent those components of T2 and T1. So T2 will have one component which is going to act in this direction. Let me represent it in some other color. This will be T2x. Similarly, T2 will have one component which is going to act in the positive z direction, right? T2 will have one component in the negative I. This is in the negative I, and this is in the positive K. So let me try this. This will be T2z. Similarly, T1 have 3 components. So this is T1 will have one component which is acting in the negative x. This is in the negative x, minus 6 divided by 7 T1. So let me write that this green one is T1x. Similarly, T1 will have one component in the negative j. So in the negative j, that will be acting in this direction. So this one will be this blue one will be T1y, and similarly this T1 will have one component which is acting in the positive z. So this blue one will be T1z. And similarly, we can resolve this 400 Newton into its components. So it will have one component which is going to act in the downward direction. This one will be 400 cos of 30. And this will have one component which is going to act in this direction, that is in the positive y. So we need to show it here. This one is 400 sine of 30, and 400 sine of 30 will give us 200 newtons. So this is 200 newtons. So this 400 Newton force is acting in the yz plane. So it have one component along the y and one component along the negative z. Now we are required to find T1 and T2. So if we find the moment about the z-axis, we will be able to find T1 directly, T1 magnitude directly. Since if we find the moment about the z-axis, then all these 3 components, these reaction forces are passing through the z-axis, and this T1x and T2x, they are passing through that z-axis, and T1z and T2z, this pink one is T2z, they are parallel to the z-axis. They are not going to produce the moment about the z-axis. Let me write this T2z here. This pink one is T2z. So this x components and these z components, they are not producing the moment about the z-axis. This 200 Newton, this is producing the moment about the z-axis. This component is parallel to the z-axis. So as we know that that force or component which is parallel to a particular axis is not going to produce the moment about that particular axis, and the force or the component which intersect with the z-axis or with that axis about which we want to find the moment, they will not produce the moment about that particular axis. So the x components are passing through that z-axis, are intersecting with the z-axis, so they are not going to produce the moment about the z-axis. And T1z and T2z, they are parallel to that particular axis, that z-axis, so they are not going to produce the moment about the z-axis. So only T1y and this 200 Newton force, they are going to produce the moment about the z-axis. So now let's find the moment. The summation of moment about the z-axis will be equals to 0. Further, if we look into this, so in other words, we can say that T2x is intersecting with the z-axis, and T2z is parallel with the z-axis. So from this we can say that T2 is not going to produce the moment about the z-axis. So if the components are not producing the moment about the z-axis, so T2 is not going to produce the moment about the z-axis. And in another way we can say that this T2 is intersecting with the z-axis. So if this T2 is intersecting with the z-axis, so it's not going to produce the moment about the z-axis. And obviously if this T2 is not going to produce the moment about the z-axis, its components are not going to produce the moment about the z-axis. So if we apply the summation of moment about the z-axis, we will have only one unknown, T1. Since these three unknowns, they are not going to produce the moment about the z-axis, this T2 is not going to produce the moment about the z-axis. So only this T1y, which is unknown, is going to produce the moment about the z-axis. So now as we can see that this T1y is going to produce the moment about the z-axis in this direction, like this. And if we curl our right hand fingers in this direction, so the thumb is going to point out in the negative z direction. So this means that T1y is producing the moment about the z-axis in the negative z direction. So we will write minus T1y, and the perpendicular distance of T1y from that z-axis is this 6 meter distance, this length of the rod. So I have to multiply this T1y with 6, and this method is known as the scalar method. So you people must keep in mind that we are solving this problem by considering the scalar approach, and the scalar approach is the moment determined by its value, the force value times the perpendicular distance. So this is T1y multiplied by its perpendicular distance, and T1y is producing the moment in the negative z direction. So that is why we are putting minus sign here. And similarly, this 200 Newton force is producing the moment about the z-axis in this direction. It's going to rotate the system in this direction, like this. So if we curl our right hand fingers in this direction, so the thumb is going to point out in the positive z. So this is producing the positive moment, that is the counterclockwise moment about the positive z-axis. So we will write plus 200, and the perpendicular distance of this 200 Newton force from that z-axis is this distance, which is again 6 meters. So I will multiply this with 6, and this is equal to 0. So from this we can say that T1y is, if we divide this whole equation by 6, so T1y is equal to 200 Newton. And similarly, if we know T1y, which is the y component of T1, and the y component of T1 is equal to minus the magnitude of the y component of T1 is 3 divided by 7 T1. This minus sign tells us the direction. So now from this equation we can write that this is 3 divided by 7 T1 equals to 200. And similarly from this we can write that T1 is 200 into 7 divided by 3. So 200 multiplied by 7 divided by 3 gives us T1 magnitude, which is equal to 466.67 newtons. So this is the tension magnitude and the cable which is acting from A to B. Now to find T2, again, if we find the moment about the y-axis, if we determine the summation of moment about the y-axis, that must be equal to 0. And now we know T1. So if we know T1, we will be able to find T2 if we apply the summation of moment about the y-axis. Since these three unknowns, they are intersecting with the y-axis and that are not going to produce the moment about the y-axis. And now all those components which will be intersecting with this y-axis is not going to produce the moment about this y-axis, and the components which are parallel to the y-axis are not going to produce the moment about the y-axis. So this 200 Newton, this is parallel with the y-axis, this T1y is parallel with the y-axis, and this T1x and T2x, they are intersecting with the y-axis. So T1x, T2x, 200 Newton, and this T1y, they are not going to produce the moment about the y-axis. So only the z components, T1z, T2z, and this cos component of this 400 Newton force is producing the moment about the y-axis. So now we can write that if we apply the summation of the moment about the y-axis is equals to 0. So this will give us t2 now. So again, as we can see that this t1z is going to produce the moment about the y-axis in this direction like this, and if we curl our right hand fingers in this direction, so the thumb is going to point out in the negative y direction. So this means that t1z is producing the negative moment, that is the counterclockwise moment about the y-axis. So now we can write that minus t1z, and the perpendicular distance of this t1z from that y-axis is this 6 meter distance. So we will multiply this with 6. Let me write it here. And similarly, this t2z is going to produce the moment about the y-axis like this. And again, if we curl our right hand fingers like this, so the thumb is going to point out in the negative y. So t2z is again producing the clockwise moment about the y-axis. So you will write minus t2z, and the perpendicular distance of this t2z from that y-axis is this 6 meter distance. So we will multiply this with 6. This is the moment arm of t2z, and this cos component is going to rotate the system about the y-axis like this. So if we curl our right hand fingers in this direction, so the thumb is going to point out in the positive y direction. So this means that this cos component is producing the counterclockwise moment about the y-axis. So we will write plus 400 cos of 30 degrees, and the perpendicular distance of this cos component from that y is again 6 meters. So we will multiply this with 6 as well. So this is equal to 0, and if we divide this whole equation by 6, so we will be left with minus t1z minus t2z and plus 400 cos of 30 degrees, and this is equal to 0. So if we want to find t2, we know t1, so we can write that minus t2z is equal to 400 cos of 30 plus t1z. And if I multiply both sides of equation by minus, so this will become plus, this will become minus, and this will become minus. So we will have the equation like this. Now as we know t2z, this is t2z, 2 divided by square root 40 into t2. So let me write that this is 2 divided by square root 40 into t2. This is the magnitude of t2z. This is equal to minus 400 cos of 30 and minus t1z. So now t1z, this is t1z, 2 divided by 7 t1. So we can replace this t1z by 2 divided by 7 t1, and we know t1 magnitude, which is 466.67. so this is 466.67. so let's find the right hand side of this equation. So minus 400 cos of 30 minus 2 divided by 7 into 466.67. This gives us minus 479.74. Let me write it here. This is minus 479.74. And since we want to find T2, so this will be minus 479.74. We did a small mistake here. If this is minus T2z, so if I bring this to the other side of equation, this will become minus and this will become plus. So let me justify that equation. So this will be minus 400 and this will become plus, and we will be left with minus. So now if we multiply this whole equation with minus, this will become plus and this will become minus. This will become minus. So now this is plus and this is minus. So let's change the signs. So this is 213.07. now this is 213.07. and now to find T2, we need to cross multiply this with square root 40 divided by 2. So now this answer multiplied by square root 40 divided by 2 This gives us T2 equals to 673.81 newtons. This is T2. Now we have determined T1 and T2 using these two equations very smartly. If we the summation of moment about the z equals to 0 and the summation of moment about the y equals to 0, and using the scalar approach. Now we have to find the x, dy and dz. Now once we know T1 and T2 magnitudes, we can easily find dx, dy and dz if we apply the summation of forces along the x, y and z. Let me copy this this photo. So this is, now we can apply the summation of forces along the x-axis equals to 0. So now the dx is acting in the positive x. This dx is acting in the positive x, so we will write plus dx minus t1x minus t2x. So minus t1x minus t2x, this is equal to 0. Or we can say that dx is equal to t1x plus t2x. Now t1x, we know that t1x in terms of t1 is 6 divided by 7 t1. We only need to consider the magnitudes, since we have considered the directions already while applying the summation of forces along x. So dx is equal to t1x, which is minus 6 divided by 7 t1. This is 6 divided by 7 t1. We know t1, which is 466.67 plus t2x. So t2x is this is minus 6 divided by square root 40 into t2. So this is 6 divided by square root 40 into t2, which is 673.81. So this will give us 6 into 466.67 divided by 7 plus 6 into 673.81 divided by square root 40. This gives me 1039. dx comes out to be 1039.24 newtons. This is dx. Now if we apply the summation of forces along the y-axis is equals to 0. So dy is acting in the positive y. This is our dy. So dy plus this is dy. Remember, this is dy. So dy plus t this plus 200. 200 is acting in the positive y, and then minus this t1y. So minus t1y, this is equal to 0, or we can say that dy is equal to t1y minus 200. And as we know, somewhere here we have determined that t1y is equal to 200. So t1y is equal to 200. So this is 200 minus 200. So this means that dy is equals to 0 newtons. So there is no reaction in the y direction at that ball and socket joint at D. Similarly, if we apply the summation of forces along the z-axis is equals to 0. So again this dz is acting in the positive z. So I will write plus dz. Then t1z and t2z, they are acting in the positive z. So plus t1z plus t2z. And minus that cos component. This is 400 cos of 30. So minus 400 cos of 30. This is equal to 0. And from this we can say that now if we look into this equation, so if I bring this 400 cos of 30 to the other side of equation, let me write this equation in this particular form. This is t1z minus t2z equals to minus 400 cos of 30, and if I multiply this whole equation with minus, so everything will become positive. So from this is we can see that t1z plus t2z is equal to 400 cos of 30. So now T1z plus T2z is 400 cos of 30. So 400 cos of 30 minus 400 cos of 30 will give us 0. So this means that dz, the reaction in the z direction, is also equals to 0 newtons. So now dx is 1039.24, dy is 0, d2 is 0, and T1 is 466.67 newtons, and T2 is 673.81 newtons. So this is the solution of this particular problem. Using the scalar approach, you people can find the same solution by applying the vector approach. So do apply the vector approach and let me know that if that gives you the same answer in the comment section.